So in this class, so we discuss exercise 5.1 from 6th problem onwards. Here question number 6 to question number 12. Question number 6 to question number 12. Find all points of discontinuity of the given function f where f is defined by, is the question number 6. Here f is given function. Here check for what points f of x is not continuous or f of x is discontinuous. So find all points of discontinuity of the given function f of x. Here the given function f of x is equal to 2x plus 3 when if x is less than or equal to 2, 2x minus 3 if x is greater than 2. When x is less than 2, here what is the domain of this function? So this is real number line minus infinity to plus infinity. Here the point is 2. When x is less than 2, so this is x less than 2. F of x is, here f of x is 2x plus 3 is a polynomial. When x is greater than 2, f of x is 2x minus 3 is a polynomial. So x is less than 2, x is greater than 2 and x is equal to 2. Function is defined. When x is less than 2, polynomial function domain is set of all real numbers. So the function, if x is less than 2, f of x is defined. When x is greater than 2, f of x is equal to 2x minus 3 is a polynomial. So domain is set of all real numbers. Therefore at x is equal to 2, f of x is a polynomial. Therefore the function f of x is defined for all real numbers. Domain is set of all real numbers. In all real numbers, x is less than 2, that means this point, x is less than 2, the function f of x is 2x plus 3 is a polynomial function. We know that every polynomial function is continuous. Therefore f of x is equal to 2x plus 3 is continuous in the interval minus infinity comma 2. So between minus infinity comma 2, take any real number between minus infinity and plus 2. So f of x is a polynomial, is continuous. So less than 2, function f of x is continuous. Greater than 2, so that means this value. Greater than 2, f of x is a polynomial function. So in both the cases, f of x is a polynomial function. So f of x is continuous function. In the intervals minus infinity, less than 2, f of x is continuous, greater than 2, f of x is continuous. So we have to check the continuity at x is equal to. So at x is equal to 2, we don't know it is continuous or not. Less than 2 is a polynomial, greater than 2 is a polynomial. We know that every polynomial function is continuous. So we need to check the continuity of a function at x is equal to 2 only. So at x is equal to 2, f of 2 value. Here 2 is less than, so x is equal to 2. When x is equal to 2, the function is 2x plus 3. F of 2 is equal to 2 into 2 plus 3. That is 4 plus 3 is equal to 7 is the real number. The function is defined at x is equal to 2. Next find the left hand limit and right hand limit. Because the given function f of x is a classification form. Here left hand limit is limit f of x as x tends to 2 minus. X tends to 2 minus means x is less than 2. When x is less than 2, the function is 2x plus 3. So f of x is 2x plus 3 as x tends to 2 by direct substitution method. So 2 into 2 plus 3, the value is 7. Left hand limit exists and right hand limit is limit f of x as x tends to 2 plus. That means x is greater than 2. If x is greater than 2, the function is f of x is 2x minus 3 as x tends to 2 by direct substitution method. So 2 into 2 minus 3. So 4 minus 3 value is 7. Your LHL is not equal to RHL. So therefore f of x is not continuous at x is equal to 1. at x is equal to 2 only. At x is equal to 2, the function is not continuous. So from this problem, x is less than 2, f of x is a polynomial continuous, greater than 2, f of x is a polynomial continuous. At x is equal to 2, the function f of x is not continuous. Therefore, what is the point of discontinuity of this function f of x? At x is equal to 2 is the only point of discontinuity for this function f of x. Therefore, f of x, the point of discontinuity is of f of x is x is equal to 2. X is equal to 2 is the only point of discontinuity of the given function f of x. So this is the problem. Next, question number 6, question number 10, question number 11, question number 13, same model problems you have to solve. So this type. Next, question number 7 problem. 7th question. F of x is equal to modulus of x plus 3 if x is less than or equal to 3, minus 2x if minus 3 less than x less than 3. So this is minus 3. Next, 6x plus 2 if x is greater than or equal to 3. What is the domain of this function? So if the points are minus 3 plus 3, so only two values, minus 3 and plus 3, less than minus 3, this is the point. At x is equal to minus 3, f of x is polynomial function defined. Between minus 3 and plus 3, between minus 3 plus 3, f of x is a polynomial defined. X is greater than 3, x is greater than 3 is equal to 3, is equal to 3, is equal to 3 is a polynomial, and greater than 3 is also polynomial. So therefore the function is defined for all real numbers. Domain of this function f of x is set of all real numbers. Next, when x is less than minus 3, when x is less than minus 3, f of x is equal to modulus of x plus 3. When x is less than minus 3, what is the definition of modulus of x? Modulus of x is equal to x if x is greater than or equal to 0, minus x if x is less than 0. Here x is less than minus 3 means x value is negative. If x is negative, modulus of x is minus x, that is minus x plus 3. So this is f of x when x is less than minus 3 is a polynomial. Next, when x lies between, when minus 3 less than x less than 3, x lies between open interval minus 3 comma plus 3, so f of x is minus 2x is polynomial, is a polynomial. We know that every polynomial function is continuous. Next, when x is greater than 3, f of x is equal to 6x plus 2 is a polynomial. So in this interval, that means what? Minus infinity to minus 3. So open interval minus 3 to minus infinity to minus 3 is a polynomial. Next, open interval minus 3 to plus 3, minus 3 to plus 3 is a polynomial, is continuous. Next, greater than 3, plus 3 to plus infinity, plus 3 to plus infinity, open interval 3 to infinity is a polynomial. So therefore in these intervals, f of x is in all the cases f of x is a polynomial function. So f of x is continuous function in the above intervals. What are the above intervals? Open interval minus infinity comma minus 3, open interval minus 3 comma 3, open interval 3 comma infinity. Continuous function in the above intervals. So we need to check the continuity at x is equal to minus 3 and at x is equal to 3 only. So between these two is continuous, between minus 3 to plus 3 is continuous, between 3 and infinity is continuous. We have to check the continuity of a function at x is equal to minus 3 and at x is equal to plus 3 only. At x is equal to, so first at x is equal to minus 3 is continuous or not. At x is equal to minus 3, what is f of minus 3? At x is equal to minus 3, function is modulus of x plus 3. So modulus of minus 3 plus 3, modulus of minus 3 value is plus 3 and plus 3 the value is 6. So the function is defined at x is equal to minus 3. Next, if the given function is classification form, whenever the given function is classification, so find the left hand limit and right hand limit. So what is the left hand limit? Limit f of x as x tends to minus 3 minus, that means x is close to minus 3, left side, x is less than minus 3, the function is modulus of x plus 3, that is limit modulus of x plus 3 as x tends to minus 3. X is less than minus 3, that is negative value, modulus of x is minus x plus 3 as x tends to minus 3. By direct substitution method, minus of x is equal to minus 3 plus 3, that is plus 3 plus 3 value is 6, left hand limit is exist, and right hand limit is limit as x tends to minus 3 plus f of x. That means what? X is greater than minus 3. X is minus 3 is less than x is same as x is greater than minus 3. X is greater than minus 3, the function is minus 2x. So that is limit as x tends to minus 3, function is minus 2x. By direct substitution method, minus 2 into x is equal to minus 3, so that is plus 6. So clearly LHL is equal to RHL is equal to f of minus 3. Therefore f of x is continuous at x is equal to minus 3. So therefore in this interval continuous, close in open interval minus 3 comma 3 continuous, open interval 3 to infinity continuous, at x is equal to minus 3 also continuous. So we need to check another one point at x is equal to 3. Suppose if at x is equal to 3 is continuous, there is no point of discontinuity of this function. Suppose at x is equal to 3 is not continuous, there is only one point, at that point the function f of x is discontinuous. Next we have to check the continuity at x is equal to plus 3. At x is equal to 3, f of 3 at x is equal to 3, function is 6x plus 2. F of 3 is 6 into 3 plus 2, because at x is equal to 3, function f of x is equal to 6x plus 2. Here substitute x is equal to 3, 6 into 3 plus 2, 6 3s are 18 plus 2, the value is 20 is defined. Left hand limit is x tends to 3 minus, function value x tends to 3, that means x is less than 3, function is minus 2x, direct substitute x is equal to minus 3, minus 2 into 3, the value is minus 6. Left hand limit exists, that value is minus 6. Right hand limit is 3 plus, that means x is greater than 3, function is 6x plus 2, 6x plus 2, x tends to 3. By direct substitution method, so this value is 6 into 3 plus 2, the value is 20. Here clearly LHL is not equal to RHL, so therefore f of x is not continuous at x is equal to 3. So therefore in this domain, in the set of all real numbers, only the point of discontinuity is x is equal to 3. So remaining, take any point in this domain except 3, the function f of x is continuous. Therefore the point of discontinuity is, so therefore the point of discontinuity of f of x is x is equal to 3. So only this is the point at which the function f of x is discontinuous. Next, question number 8, 9 same model. So take 9th question. Question number 9. F of x is equal to x by modulus of x if x is less than 0, minus 1 if x is greater than or equal to 0. So find all points of discontinuity of the function. Here the domain is, so this is 0 only one point, less than 0, so this is the f of x is equal to x by modulus of x is a polynomial function, greater than or equal to 0, so including 0 greater than 0, therefore this is the set of all real numbers. Domain is set of all real numbers. Next, when x is less than 0, what is f of x? Modulus of x by x. X is less than 0. What is the definition of modulus function? Here modulus of x is equal to x if x is greater than or equal to 0, minus x if x is less than 0. If x is less than 0, what is the modulus of x? Sorry, x by modulus of x. So this is f of x is equal to x divided by, when x is less than 0, modulus of x value is minus x. So x get cancelled, that is minus 1. So when x is less than 0, function is minus 1 is a constant function. Is a constant. Next, when x is greater than 0, when x is greater than 0, f of x is equal to minus 1 is also constant. Is a constant. In both the cases, f of x is a constant function. Is a constant function. So we know that every constant function is continuous for all x belongs to R. So f of x is continuous function in the above intervals. So therefore, x is less than 0, f of x is a constant function, is continuous. Greater than 0, f of x is a constant, is also continuous. We need to check the continuity at x is equal to 0 only. At x is equal to 0, what is f of 0 value? At x is equal to 0, f of x is minus 1. f of 0 value is minus 1. The function is defined at x is equal to 0. Next, whenever the given function is classification form, left hand limit and right hand limit. Left hand limit is limit as x tends to 0 minus f of x. When x is less than 0, the function is limit x by modulus of x. X is less than 0, x divided by modulus of x is minus x as x tends to 0. So that is limit as x tends to 0, x by minus x is equal to minus 1. Limit of constant function is constant itself. Left hand limit exists. And right hand limit is limit as x tends to 0 plus f of x. X is greater than 0, f of x is minus 1. So limit minus 1 as x tends to 0, limit of constant is constant itself. So therefore, clearly LHL is equal to RHL is equal to f of 0. All are equal. Therefore, f of x is continuous at x is equal to 0. So therefore, less than 0 continuous, greater than 0 continuous, at x is equal to 0 also continuous. Therefore, there is no point of discontinuity of f of x. Therefore, there is no point of discontinuity of f of x. So there is no point of discontinuity of the given function f of x. F of x is continuous at every point of its domain. So therefore, we say that f of x is, there is no point of discontinuity for this function. Next, question number 13. Just type. Huh? Okay. Question number. Question number 13. Question number 13 is the function defined by f of x is equal to x plus phi if x is less than or equal to 1, x minus phi if x is greater than 1, a continuous function. Your given function f of x is defined. This is f of x equal to x plus phi if x is less than or equal to 1, x minus phi if x is greater than 1, is a continuous function or not, is the question. Right. When x is less than 1, f of x is x plus phi is a polynomial function. Next, when x is greater than 1, f of x is x minus phi is a polynomial function. So less than phi is continuous because f of x is a polynomial, greater than phi is a polynomial, is continuous. We need to check the continuity at x is equal to phi only. So in both the cases f of x is a polynomial. So f of x is continuous in the above intervals. So we need to check the continuity at x is equal to 1 only. At x is equal to 1, what is f of 1 value? F of 1 is equal to, at x is equal to 1, function is x plus phi. F of 1 is equal to 1 plus phi, the value is 6. Next, whenever the given function is classification form, find LHL and RHL. Left hand limit is equal to limit as x tends to 1 minus f of x. X is less than 1, the function is x plus phi. So that is limit x plus phi as x tends to 1, by direct substitution method 1 plus phi value is 6. RHL is limit as x tends to 1 plus f of x, that is limit when x is greater than 1, the function is x minus phi as x tends to 1, direct substitution method 1 minus phi is equal to minus 4. So therefore clearly LHL is not equal to RHL. So therefore f of x is not continuous at x is equal to 1. So therefore here f of x is continuous function, for all x belongs to set of all real numbers other than 1 or minus 1. So given function f of x is continuous for all real numbers except 1, because at x is equal to 1 the function f of x is discontinuous except 1. Take any real number less than phi or greater than phi. So less than 1 and greater than 1, f of x is continuous. At x is equal to 1 the function is discontinuous. So f of x is continuous function for all x belongs to r minus 1. So these are the problems. Thank you.